Welcome all. My name is Frank Crawford. I am the Education Committee Lead for Passive House Alberta, and welcome to today's Coffee Talk. I'm extra excited today just because we get to show off what myself and a number of other people have been doing over the past kind of like year and a half. And that is creating about 2 hours of high performance construction and passive house videos and compiling them into a series. And of course, I need to start by saying a great thank you to SSRIA, the Smart Sustainable Resilient Infrastructure Association, who provided the funding for this project. Without them, it would not exist. So what are the videos and kind of what makes us a little bit different than some of the other videos? Because obviously there's a lot of stuff out there these days. So when we started, some of you have actually assisted with this, but we sent out a survey to the industry within Alberta to see kind of what was missing from the videos and training courses right now. And that's kind of guided us to what we created. We are product agnostic. There is no product funding. It's not marketing hype. So obviously there are products in the videos because when people build stuff, they use products and those products have names on it, but we didn't get any funding from it. It was product agnostic. It was kind of looking on what the techniques and processes were used, not just the product itself. As much as we could, we went into more specific details. There are pretty pictures, but it isn't just pretty pictures. There are details on how you actually do specific tasks and apply specific materials. And it's all based on building science and thermodynamics because we are passive house builders and high performance builders, and this is how we do things. And also, there's been a few reviews and multiple edits, so it was reviewed and edited by industry experts. So hopefully we feel that we're very confident and proud on the stuff that we have created, and we believe that will be helpful to the industry. So what is actually available? So there's 2 hours, 2+ hours of videos showing kind of cold climate, high performance construction and passive house techniques and processes. And it's segmented into short individual kind of bite-size bits, kind of 30 seconds to kind of 5-10 minutes, and also kind of longer compilation videos on different locations in different areas. And those kind of are kind of the 5 minutes to like 37 minutes long. So depending on what your use for them are, that's why we put them into both these options. And some of the topics that were covered are air tightness, wall assemblies, window installation, thermal bridge, mitigation, integrated project delivery, HVAC systems, and deep energy retrofits. So kind of what's the goal of these videos and what are we actually offering? So the goal was to improve the skill level of trades and designers working in cold climates, specifically Alberta, but kind of all of Canada and beyond. And educational institutions or organizations or individuals can purchase access to the video library and use it within training courses and programs. It's not a complete training program in itself, but it definitely can supplement existing training courses. And as you try to take those training courses from kind of like code minimum up to the higher performance and passive house levels. So the fees to have access to these vary by groups and access needs. Basically, the access is view only or view and download. And the nice thing is that once you purchase the download options, once you download those videos, you can re-edit them kind of to best suit your needs. So we're not kind of restricting the use once you've paid for the download access. And now kind of the fun part, how do you actually get to them? So for those that are members of Passive House Alberta, you get free view-only access. We'll be doing it through Vimeo, I believe. So for those that are Passive House members already, in the next few weeks, you'll be getting an email. And if you aren't currently a member, membership is only $40 for individuals, $25 for students, and started about $500 for corporations. So you might be a good time to get a membership to Passive House Alberta to get view-only access to all of these videos. If you are more of a educational institutions or a larger company that might want to use these in a larger context for educational training, then the cost is either $1,000 for all 2+ hours, or if you just want one single video, it's $295, and that is download and edit access. If there is anyone here from NAIT or SAIT or other educational institutions, if you hear from SAIT or NAIT, You guys are lucky. We have already negotiated that all SAIT and NAIT instructors have free download access to all these videos. Tomorrow, I am hosting a webinar with the SAIT instructors to kind of introduce them and kind of discuss how they can be used. And if you're from NAIT, then the webinar is going to be June 7th, I believe, to kind of introduce these videos and show you how to use them. If you just become the member, you get to view only. So you can look at them and see if you want full access from there. If you have any questions on that, at the end, you can send it to education@passivehousealberta.com. So the videos, we will be using the Vimeo video platform. It's a nice platform. You can have a free account on there, and on that platform, it allows you to view all of the videos there. They will be password protected. We don't want kind of everyone getting into there. And if you are purchasing the full videos and want to use the Vimeo website, we can, to some degree, customize how that website looks like to kind of your company colors or your company logos, stuff like that. We don't want people just to kind of post these videos on the internet or any other free public sharing access. The reason is that we try to be complete in all of the videos, but there is always some context. So if there's not kind of someone that is acting as kind of the educator or the trainer or the instructor, some of that context is lost. So that's why at this point, we don't want anything just publicly posted. That was a really easy part. Now let's actually start to watch the videos. So what we're going to do kind of for the rest of the day is I don't just want to chat. I want it to be kind of more of a conversation. We'll watch a video and then we'll kind of bring it back and see if people have any questions or comments about that video. We can kind of get a snippet of what the videos are going to be like. All right, so here is the first one. So it's talking about above grade walls. So that's kind of how we've distributed the videos, like above grade walls, below grade walls, foundations, and windows. So you can kind of search it within that Vimeo platform. There is a search function, and all of the longer videos are sorted to the front. They're just numbered 1 through 9. Here is the first video.
So in any deep energy retrofit, one of the first steps that you have to do is kind of disassemble a little bit just so that you can actually find out what is on site and what's existing. So for this project, once we removed the existing siding, we did find that in some parts there was stucco. The stucco was determined to be airtight enough that anywhere that we came across cracks, we were able to seal them. For another portion of the house, we just found wood. So in that case, we applied a liquid applied air barrier. For this attic space here, what we ended up doing is removing the sheathing so that we had access to the attic, and that allows us to gain access as well as remove any insulation that needed to be fixed. It will be reapplied, and then we will be air sealing it once we're done the project. So this detail here, we're able to see how with the existing window, we're able to tie it into the stucco so that we have a continuous air barrier. We did use the EIFS tape. We did find that the adhesion between the EIFS tape and the stucco wasn't enough to get a really solid air barrier. So this is where we used the liquid applied flashing. So here with this detail, you're able to see a drainage gap in between the existing wall as well as the insulation layer, and this is created by the trowel marks when the cement is actually applied, so that any moisture that comes out of the wall is able to drain down and out.
So what I really liked about that video is, first of all, that Celia is one of 2 trades women that are actually part of Peter Darlington's Solar Homes crew. So it's not just trades men, it's trades women working on these deep energy retrofit projects. This is what that project was. And it's also showing that when it comes to air control layers, it's not just one material. It's always a combination of materials that go together to create that continuous air control layer all the way around the building.
A lot of what I deal with often is not necessarily one system, but transition between systems. So that video delineated a couple different potential systems there. I would be interested on how the transition between stucco and sheathing air barrier happened. Any penetration details, that sort of thing. That would have been really integral. That's where these systems tend to fall down.
Yeah, so obviously that's just the shorter one. There's, I think
Right.
we're at that location for 15 minutes, and we do spend a lot of time showing the majority of the locations there. They use the yellow stuff is the individual goo, not the correct term, but they also have just a large different type of trowel on air tightness membrane that generally goes over top of all the sheathing. They have that black stuff and also a fiberglass tape that transitions over the joints. So we do show how they kind of transitioned over a bunch of materials to make sure that you do get, that continuous air barrier. There's also another one that's actually a really nice detail on how they continue that air tightness at the wall to roof detail, and how they brought the spray foam kind of to the wall, connected to spray foam the back of the insulation that was butted up. So yes, definitely the continuity of air barrier and the connection, all the details is paramount, and we do go into more detail within the video.
Second question, if I can sneak it in, how do you determine the air tightness specific to the stucco wall? Do you isolate that?
We didn't have a hard air tightness targeted on that building, but we did still do pretty good. I think it was slightly under 1.5 ACH 50.
So you tested
There you
the,
The house as a whole, that's correct,
yeah.
yes.
Okay, so you didn't isolate the one assembly. Okay, that's all.
That's correct.
Just curious.
Did you test the stucco beforehand, or I guess you just tested it before you put all the insulation over it? Or I guess, how did you make sure that if it ended up leaking that you could still repair it?
To be honest, we kind of just went for it, and it was like an inch thick stucco because this specific building wasn't chasing any labeling program. If it ended up landing at 1.3 or 1.7, as long as there wasn't any, like real hard leaks through any of that space, which, again, we took care of with all that liquid applied at the perimeters. So yeah, I think we started around 4 air changes and we ended around 1.5 on that particular building.
Oh, even starting at 4 is pretty good. But yeah, inch thick stucco where it doesn't have cracks is pretty good. Marth has a question about translating into different languages. So we haven't thought about it at this point. Actually, one nice thing is Vimeo actually provides automatic subtitling. So, looks like Cheryl says it looks like Vimeo might already support some additional languages on the subtitles. So thank you for that. We're not likely going to redub it into different languages, but you can definitely get the subtitles automatically straight from Vimeo. And from there might be subtitles in different languages options. I'm not sure. Let's look at another one.
As we continue out this deep window rough-in, the plywood that we saw from the inside is acting as a combined air and vapor barrier. So all of the joints have to be taped with a high-performance, vapor-open, stretchy tape. To increase the insulation, they make a cavity. The cavity is made with a TGI or a wood I-beam, and then this cavity will be covered with wood fiberboard and a weather-resistant barrier. The cavity will be filled with dense packed cellulose. So when you take all these different insulations, it ends up with a very high-performance wall system that's called either a TGI outrigger or an I-beam outrigger, or sometimes just another type of split insulated wall. From the inside, this is a very typical 2x6 framed wall. They still try to use advanced framing techniques to minimize the amount of lumber, but it is your basic standard construction. But if we come to this window, you can see that it's sheathed with plywood, and you can tell by how deep it is that it really isn't a code minimum wall.
So what I liked about that one is it kind of brings up the concept of both a combined air and vapor barrier. And in this case, it's actually a combined smart air and vapor barrier in the use of the half-inch thick or thicker plywood. It's showing a relatively innovative wood I-joist and the dense packed cellulose wall assembly, showing how that plywood is transitioned out. And there's another video in this series to show how we connect all the membranes at that wall assembly. We might actually show that later today. This one was a different single family home, new build. Questions on this one? What's the permeance of the plywood? So plywood is what is called a smart vapor barrier. And a smart vapor barrier is any material that its permeance changes based on the relative humidity of the cavity on either side. So plywood, when it's over ½ inch thick, and OSB, when it's over, I think 7/16, basically ½ inch thick, has a permanence rating less than 1 perm. Less than 1 perm is what Canadian Code classifies as a vapor retarder, or can be used as a vapor control layer. It's a natural smart vapor barrier in that as the relative humidity, for whatever reason, happens to increase within the cavity, if we have a leak or for some reason moisture is accumulated in it, the pores in that OSB or plywood open up, and it opens up to about, I think, 17 perms. So much more open, allowing the moisture that might have got into the wall by whatever means to dry out to the inside. So that's one of the advantages of the smart vapor barriers, is it allows increased drying to the inside, generally in the summer, if the wall cavity happens to get wet for any reason. So Leah has a question about how smart vapors function in our Chinook environments. So again, it all has to do with that moisture content in the walls. So hopefully the smart vapor retarder is still on the inside, the vapor control layer side, and we will still have often, and in this building we don't, they still have a WRB on the outside and is acting kind of as a secondary air control layer, but you almost always have a WRB or your primary air control layer on the outside, and those materials are even higher perm ratings, so somewhere around the 50s or at least the high 20s, so that the lowest perm rating is the inside of your wall, that is the vapor barrier, and every single material further outboard has a higher permeance, so we're controlling the moisture entering the wall with our vapor barrier, and then we're never giving it a material to slow down the ability to dry. So by having those higher permeance membranes further outboard in the Chinook, it would actually help dry the wall to the outside in the winter during the Chinook, and it would still, if moisture did happen to accumulate, it would still allow moisture to dry out to the inside. But in the Chinook, we're probably not getting warm enough drying to the inside, it would still be drying to the outside. So the plywood, again, is only part of the membrane. It needs to be taped with those high performance sticky tapes to make sure that we have that long-term 50 to 100-year durability of that membrane. Some of you might know the kind of the 1/3, 2/3 rule. So as long as we have enough insulation outboard of the vapor barrier, then it can also act as the combined air and vapor barrier, which is what we're doing in this case. We have about 5.5 inches of cellulose on the inside in that 2x6 cavity, and about, I think it's a 9.5 inch TGI, so 9 inches of cellulose on the outside, plus another R4 from the wood fiber board. So lots of insulation on the outside to make sure that the ratio is met. Questions while I post the wall assemblies. So kind of, I'll show one more video that shows it a little bit better, and then I will show something else. Question, what municipality was this in, and were there any inspections issued with the vapor barrier? So this was in the Bragg Creek area, so I think that is Foothills. So went through the full building permit stage, all the stages, and there weren't any concerns. They might have, just like Calgary, they might have had to break up the pre-board mechanical and electrical inspection from the pre-board installation inspection, but with this wall assembly, it wasn't that complicated to break it up. It will vary kind of from jurisdiction to jurisdiction on whether or not you have to break up some of those building permit inspections. Okay, let's finish this. So here's the window installation in this wall.
So this deep wood window rough-in buckout serves a number of purposes. The primary purpose, obviously, is to transfer the vapor barrier from the inside to the outside, because the plywood is a vapor barrier when it is taped with high-performance tape. The second function is that when the weather-resistant barrier that's going to be applied to the outside is returned back in, it connects that membrane from the outside to the inside. Finally, it gives us lots of structure to be able to install our high-performance triple-pane windows anywhere within that rough opening. Ideally, the windows are installed in the thermal center of the wall, because that is where they are the highest performing, but that might change within an inch or two depending on the actual window install detail. Talking about windows, there's a number of different factors that makes up the total performance of that window. Obviously, there's the glass, there's the frame, but then equally important to that is how that window gets installed. Because if you have a really high performing window and you install it poorly, the window will perform poorly. So we want to maintain the performance of that window. So here is one excellent details on how we install this window in a high performance building. So first of all, we would structurally attach the window. You can use clips or screws. There's various different methods depending on the installer. But then you want to come back and on all four sides on the inside, we use a high performance tape to connect the vapor barrier of the wall to the vapor barrier of the window, because the window is part of your air and vapor barrier system. So that tape is high performance. It is very sticky. It is stretchy. And it has similar permeance ratings as the rest of the assembly. The reason you want it really sticky is because the wall might move, the window might stretch over time, and that stickiness and stretchiness maintains the air tightness over the 50 to 100 years that this wall is going to be here and this building is going to be here. So all four sides are taped wall to the frame on the inside. On the outside, at least the top three sides are taped. The sill on the outside is dealt with a little bit differently. And then next, we want to try to reduce the thermal bridging of this installation. So on the jambs and on the head, they've installed about a ½ inch of insulation here. This helps reduce the thermal bridging of this connection detail. And then on the sill, because the outside of the sill is sloped down and you can't really insulate it out on the outside, we've put about 2 inches of insulation on the inside of the sill. And all of these details combine to make an excellent high-performance window installation detail. So here's the next progression on that window installation detail. Remember, we still have the foam here. We have the foam behind this piece of wood. We now put the drywall on. The drywall gets mudded and taped and painted. You can caulk to the seal. It's not part of the airtight membrane. It just gives a nice look. And then you might want to put a more durable material on the sill, because people often put pots or plants or something because they have a nice deep sill here. But one thing you want to make sure is you leave yourself enough space so that when you open your operable window, you're not hitting any of the materials. But you can still hide as much of that frame as you can with insulation.
All right, so for that one, you might have noticed that there were some really cool SketchUp models shown, and I agree, they are really cool. So they were made by a company called Beyond Code. Jamie from Performance House and Tucker Webb out in Vancouver or Victoria are kind of the people behind these. And what their goal is to create high performance details for builders or educational institutions. They make them in SketchUp. They have all of the layers visible. You can actually move it all around. They will actually show you the water control, the air control layers from the inside and the outside. They'll show you where all the insulation is. And then you can even use these items as kind of a virtual wall mock-up so that you can actually build the building step by step. So studs, sheathing, it walks you through basically every single step of the build. I like this detail showing that sill has a steep flashing. We try to say that it's a 4 and 12 slope, treat the sill like a small roof. So some sloped insulation. But basically it walks you through step by step every single one of the details, showing you exactly how you flash it. There's obviously a number of different ways you can flash it. This is just one of the ways, but it walks you through each step on step by step. So you can kind of use it as a virtual wall library, a virtual mock-up. You can use it for education for your trades. They give you PDFs that you can basically give to the trades on site and say, just do it this way. So this is another excellent educational tool. So if you want to have access to these, they have a growing library that you can purchase for a fairly low rate. If not, they will help you develop custom wall assembly details for any wall that you're used to using. This is another great resource that is kind of, we found it as part of the grant, and they are offering these for sale. There's the link beyond-code.net. So any questions on any of these items? Do we have details? No. Hopefully the mundane wall flanged windows are fairly well detailed. Do we touch on them? We do touch on them briefly in one of the shorter sections of the videos. Myself, we were actually at Steve Norris's house, and he used a flange window detail on his garage. So we do touch briefly on flange windows, but most of the other installation details that are shown here, because we're doing the passive house and high performance method, are the flangeless windows. So they are installed somewhere around the thermal center of the window, which, if it's a flanged on the outside, is not often the thermal center, but depending on your wall assembly, can be. Let's continue conversation about air tightness and connection of those details, and staying at the Bragg Creek, and look about kind of the connection between the walls and roof.
So continuity of the air and vapor barriers is paramount in any high performance and passive house building. So if you look up to the second story, you'll see that blue strip, and that is a strip of weather-resistant barrier that has been placed on top of the wall before the trusses are placed on it. And what that does is allows the continuity from the exterior weather-resistant barrier to be continuous to the inside weather-resistant barrier and vapor barriers, so that you get a nice airtight building. So as you can see, our wall assembly has progressed so that most of the critical barriers are complete. Remembering that the plywood sheathing on the inside is our air and vapor barrier. We have that TJI stud that is filled with a dense packed cellulose. On top of that, we have wood fiber board. And then on top of that, we have a water resistant membrane. Here we're using the SIGA membranes. It is not part of the air barrier system, and because it isn't, the staple holes and everything don't have to be sealed. If this was part of the air barrier system, then these would have to be sealed. But all it's acting is to shed any water that gets behind the cladding and strapping that's going to be installed on top of this. Look, this is a wire coming through. This is not the air tightness membrane, so it doesn't have to be taped and sealed. They probably will still tape and seal it to make sure water doesn't get inside of this, but it doesn't have to be sealed perfectly. Same thing over here, we have our two in and out for our HRVs. They aren't sealed. We'll show you how they're sealed on the inside, but here they're just penetrating. They will still be taped, but they don't have to be part of the air barrier system, because our air barrier is inboard of this.
Yeah, so that one that kind of continued on the discussion on this Bragg Creek house, showing how we are still using a WRB as part of our water control layer, or our water resistant barrier, but the air barriers are still further back. What's the exterior fiberboard for? A little bit extra R value, because this was one of the first times that we were dense packed cellulose with the SIGA membrane. So it also acts to create the cavity for the cellulose, but basically it's just kind of a little extra R value. Many places, yours as an example, would leave off this wood fiber board. So it's just kind of the R value that they might have been looking for in Bragg Creek to get the passive house. It wasn't certified, but get to the passive house standard performance metrics in a site that didn't have very good access to the sun, because there's a fair amount of tall trees. So they do have an excellent roof solar PV system, but kind of the windows didn't see a lot of sun. So to kind of get the performance metrics, they might have needed that wood fiber board, but it isn't needed in all locations. Now I was asking, how is the cavity filled? So yeah, so this location, the dense packed cellulose was installed from the outside. So before that wood fiber board went on, they would have netted it with a polyester mesh, which just kind of creates a cavity, and dense pack it from the outside. We could show it today, but within the video series is about a 5 or 6 minute series filmed at Steve Norris's house, which used a similar wall assembly on his deep energy retrofit that shows how that dense pack process goes about. It can be done from the inside to the outside. With these exterior outriggers, it's generally easier to do it from the outside. Otherwise, you're cutting holes in that plywood, which you then have to fill and seal afterwards. But you can do it from either way. It just depends which is simplest for your wall assembly. All right, so we'll kind of continue on this connection and air tightness details. Obviously, the one there, the critical one at the top of the wall, before the roof trusses go on, they put that blue flap of membrane over top of the wall, because that allows the transition of the air and vapor barriers from the inside to the outside. Because generally at the roof, your vapor barrier is often also used as your air tightness layer. And then at this location, they actually dropped a installation cavity below it, but having that flap of membrane on top of the wall before you put your roof joists or trusses on it helps you connect those membranes together. And here we're going to go to a different building. This is one in Edmonton, more kind of light multifamily, light commercial building, and show how they did kind of that similar detail at the roof wall to roof connection.
So this location, we're at the wall to roof transition, and we're seeing how the vapor barrier is made continuous around that detail. Although it can be a similar detail to at rim joists. So if you look up, these are actually the roof rafters, and behind that red tuck tape and above that is a thick poly vapor barrier always being on the warm side. So it is currently just stuck to the wall, but the vapor barrier on the wall will be attached to it. But it's there now because when these roof rafters were installed, the vapor barrier goes underneath it and up the outside the rim joist, and then back on top to connect to the roof membrane above this plywood. And then to make sure we're continuing the same R value at this rim joist or roof joist location, on the outside of that, we still have a large thickness of EPS foam outside of that vapor barrier.
So that's obviously a different wall assembly. That's actually using the SI Construction Polycore wall assembly. It is steel studs with integrated into EPS foam that come prefabricated onto site, and you just build it like large Lego blocks. Obviously, the steel studs are a thermal bridge, but they're accounted for and they're all on the inside, and then you have that thick layer of EPS foam on the outside. So you're able to continue that nice wrapping of continuous exterior insulation all the way around the rim joists or the various other penetrations and changes of walls to roof connection details. Now, I think we'll kind of continue the air tightness trend, and we'll go back to Bragg Creek and show how we actually sealed those penetrations from the inside.
Here we are, we're on the inside of the wall, and here we have the penetration for the HRV, and you can see that it has been nicely taped with high performance, sticky, stretchy tapes, ensuring a long-term airtight seal. And every penetration where we go through the building, anywhere, walls, slab, ceiling, needs to be dealt with just like this.
So that was a quick one. And obviously you can use those tapes. You can also use rubber gaskets, but basically we're looking at anytime you have a penetration going through your membranes, that we are completely sealing it with a stretchy, sticky membrane to make sure that we have that continuity of air and vapor barriers, because the penetrations are generally where you have your leaks. So I think maybe we'll switch over to maybe some mechanicals now. So we did spend some time in mechanical rooms, both on an existing building, and here is actually the retrofit at Steve Norris's building. So let's look at the mechanicals for a retrofit.
All right, we're here down in the basement where the furnace used to be, and it has been replaced with a multi-position heat pump air handler system. So the multi-position just means that this unit could go this way or run this way. So it could be installed in some fairly tight, constrained spaces, but it's running up and down now. And you starting at the bottom, you have some filters. Here you have your fan. Here you have your two refrigerant lines. And these refrigerant lines bring the hot and cold refrigerant from the outside condensing unit into the unit. Here you would have your heat pump coil. That heat pump coil either warms or cools the air that the fan blows over it. And above here we have the electric resistance supplementary heater. So on those coldest days, below kind of minus 25 with current technology, when the heat pump just can't quite keep up with the demand, the electric resistance heater will turn on a modulating amount to make sure that the temperature going out is correct to keep your house nice and toasty warm. So the other advantage using this type of equipment is it looks like a traditional furnace. So the subtrades know how to install it, and there isn't a large learning curve with it. And also you can use a traditional humidifier or a steam humidifier with this because there's enough airflow, and that allows you to control the humidity that is going out to the house, so that in our cold, dry prairie winters, we can control the humidity so it's in that nice range that we like to see. We're here in the basement, in the lungs of the house, in front of an ERV or an HRV. HRV stands for Heat Recovery Ventilator, and ERV stands for Energy or Entropy Recovery Ventilator. An HRV only recovers the heat, ERV recovers heat and moisture. And how it does that is it uses the exhaust air coming from the house. So this is the stale, warm, moist air. And it comes from the house. It goes through this membrane core in the ERV. It crosses with the supply air. Doesn't touch, but it crosses, and it allows the recovery and exchange of that heat and moisture into our supply air that is fresh, but it now leaves the machine warmer and more moist. You can also see in this unit that we have filters both on the supply and the exhaust. And those filters are there obviously to make sure that the air that's coming from outside might have contaminants like pollen or dust or dirt or smoke, but the filters take it all out so that by the time the air goes into your house, it is fresh and clean, and you end up with great indoor air quality.
Leah had another question about the tapes that we saw in the previous video. And yes, we want to make sure that those tapes do have long-term testing and will stick to the various substrates in a long-term fashion. So with that, I guess the ones that I have seen the testing for on include Proclima, the Sega brand, as well as the Rothoblast brand. So those three brands are all from Europe. They've been around since, well, Sega was started in 1966. So they've been around for a long time, and they all have kind of a 100-year test behind them to show that they do have adhesion to the various substrates for those 100 years of freeze and thaw and stretching and contracting. And if you haven't seen them, then try to get a sample, and you can definitely feel how thick the adhesive is on it. It's not a bituminous adhesive. It is a solid acrylic adhesive, I believe, which means that it actually forms a chemical bond that doesn't off gas. Like the problem with some of the bituminous and other adhesives is they're volatile organic compounds, and they might off gas and eventually stop sticking, which is why if you've seen tuck tape, which is one of these types of adhesives, after 5 to 10 years, it basically just falls right off of the poly. But all of these high performance sticky tapes have a different type of acrylic adhesive that forms chemical bonds that get stronger over time. If you come to either SAIT or NATE or some other places that we're hopefully trying to hold a Passive House tradesperson course, kind of in November, October, December of this year, we get to play with these tapes, and you can really see how well sticky they are. When I use them on my house, I actually got the tape a little bit further than I needed to on the windows, and I had to try to remove about a ½ inch of tape all the way around the frame, and it took a very long time with like goof off and a flat scraper. So yeah, I know firsthand that these tapes stick for a very long time. Yes, they are pressure activated. So a key to all of these is that you need to use a J roller or any other type of plastic card to put some pressure onto these to make sure that the pressure activated does stick. There are other North American brands of tapes that are getting better. I just haven't had enough experience with them or seen enough long-term testing to know that they work for that period of time. Steve and I guess we're kind of discussing, since for those of you in Calgary, I'm assuming that's most of you are in Edmonton, we're having some pretty bad smoke from forest fires in May. So obviously the filtration that the mechanical system provides is pretty key. So depending on what HRV or ERV you use, you get different quality of filters. For example, my Zender has MERV 13 filters, which gets most of the particulate, but not the smell. I think, Steve, do you have the Panasonic Intelligent, or what HRV do you have?
Yep, I do. Yeah, so it just has a MERV 8 in it.
Yeah, so the MERV 8 will stop all the pollen and bigger stuff, but your smaller particulate from smoke and the smoke smell will definitely be getting through it. So when you're looking to purchase equipment, check what HRV or what filtration includes, but you can also use your furnace filter to improve some of the filtration. And I guess the other part we didn't show on Steve's video is that HRV was ducted all the way around, and that was kind of the two ducts at the back of the heat pump air handler unit. So the HRV is ducted into the return air of the what used to be furnace, now air handler. So the HRV kind of uses the same ducts to move the fresh air around, and then it just uses the air handler uses recirculating to move more air when we're trying to heat or cool the unit. So I think I'll show one other one, kind of shows the breadth of the videos available, and then we can have some kind of closing comments in the last few minutes.
An integrated design process, what that means to me is the ability to get many more people at the table earlier. So the design team is integrated, the workflow is integrated, the information is shared much more openly than in a more closed system where it's design, bid, build.
Pretty common practice for larger buildings, but in a smaller project, it may not be as extensive. The most important parts of the team are the owner, the general contractor, and any of the design teams, so that might be engineers that might be involved in the project, because everyone has great input into how best to execute various parts of the project and successfully and on budget and on time.
There is a very well-defined myth that I need to keep everybody separate and bid it to death after the fact because somebody will be dumb enough to give me a low enough price that saves me money. That's a complete myth. The reality is if you invest people earlier and make them a part of your project earlier, hold them accountable to some transparency around cost and help you understand cost, you're not going to get surprises. The end result is more likely to be closer to what you expected. And you're going to have a fully invested group of trades and technical specialists as opposed to people who did a low bid and are now working for themselves.
Some people like to use the term massing in terms of what a building looks like, and if you're a passive house enthusiast, you might use the term form factor, both of which are pretty darn confusing. So I think when we're talking about what a building looks like on any site, the first thing we want to think about is orientation, where it is in the world, climate-wise. Those sorts of things are really affect the type of building and the form that the building would take.
You want the area of the external envelope, both ceiling, floor, walls, to the volume next inside the building to be as efficient as possible. After a circle, a cube is the next best shape that a building can be.
Now, in terms of achieving energy goals, the way a building is orientated and configured, the way natural shading from trees and vegetation are utilized, all these are decisions that can be made that reduce how much the energy systems of the building itself will have to compensate for. And so if you can reduce a building in terms of how it takes on solar gain, how it is exposed to wind, et cetera, and through the massing stages make these key decisions, they're intelligently linked to your final product. And then basically through smart design of all these elements, then you're not having to install systems that are really there to compensate for, frankly, what is bad design and lazy design that hasn't taken the time to maximize the building envelope performance and all these other elements.
Starting to exclude things that come out of the building from the inside to the outside, cantilevers and bump outs. Those sorts of things start to make the building more complex, more expensive, and also start to eat into the energy requirements for the building.
Passive houses, they tend to have a higher level of comfort. Now, if you chase energy efficiency far enough, and you keep health and comfort in mind with all those parameters for humidity, temperature, drafts, cold spaces and hot spaces, how it feels in your toes compared to your head. If we chase energy efficiency hard enough, the better off you are from a health and comfort point of view. Everybody wants to be safe, secure, comfortable in their home. Everybody doesn't want their buildings to be costing them too much.
Drama is a pretty interesting part of any building, and drama often means vaulted ceilings and or vaulted spaces. There's ways of doing all of those things without creating all kinds of articulations in order to keep the building compact. Illusions of vaulted space can really help in terms of form of the building. The simpler it is, the easier it is to build, the less expensive it is to operate.
And it's not that all buildings have to be square and ugly. A simple form can be beautiful, and they happen to have a reasonable area to volume ratio.
In terms of multifamily or affordable housing, decreasing the utility costs is a no-brainer. When we build better, these buildings will be robust and last for centuries.
Good. So that one was kind of more geared to, I guess, the designers and the consultants in the room, not necessarily the tradespeople. But yeah, so just kind of shows the kind of differing amounts of videos that we are presenting. So again, here's that link to Beyond Code. Look at or interested in any of those 3D SketchUp models. And then if you are interested in getting access to these videos, obviously the easiest way is just to become a Passive House Alberta member, because members are going to get free view-only access. And if you're part of an educational institution or a larger company that thinks these might be of use within your training that you're providing to your skilled tradespeople or high-performance skilled tradespeople, then definitely get in contact with us at that education at passivehousealberta.com. Do you like those videos, Leah? Do they seem to make sense? Nothing that you vehemently disagree with?
No, I'm good. God knows there's 100 different ways to do all of this. I have some thoughts maybe on the EIFS thing, but that's I think over beers to have a good discussion of. Hence the question of how do you determine the air tightness specifically of the stucco, for example. That one actually I'm very intrigued by, given how it used to be done. So
yeah, they probably are fairly airtight. With the EIFS, I always like to see that drainage layer. I think that drainage layer is key. It would be nice if our code require it, like the BC code does, but right now people can still stick stucco on a wall, put it with acrylic stucco or acrylic, put stucco on the wall using acrylic stucco that really has a very low perm and can definitely cause some problems. But once we go to EIFS and gives us that drainage cavity, which doesn't allow air to come through, it doesn't decrease the performance of the insulation, but does allow any moisture to come through and drain out, then we're getting a wall that will actually last 100 years, not one that's going to rot out in 20, and you get to come around and fix it.
fair enough. I still also want to pick your brain about these smart vapor membranes, because I do see them a lot. And my concern is that we're going to get a spike in humidity during, and because our cycles are so fast, that's what I'm worried about, is that we'll get a moment, you'll have 5 days of moisture movement through your wall, will drop back down to -30 for another 5 days. What happens with that? That's sort of the infield knowledge I'd like to know about those membranes. If anybody has feedback on that, I'd love to hear it, because I'm running into them more and more, especially with my production builders. And this is important.
Martha was asking about registering for the rest of the webinars. So if you're not already part of our mailing list, every month the mailing list goes out and you get access. We kind of tell you what the next coffee talk is going to be, and then you can join that way. It's always the 4th Tuesday of the month at this time. So we always know kind of what time it is, and you can register for each one individually, or we might be able to set up a reoccurring Zoom link. And there'll be a series dedicated solely to interfits and retrofits. So yes, there are 2 full kind of 30 minutes of video dedicated to a deep energy retrofit, one by Peter Darlington, Solar Homes, and also the one from Steve Norris from Snap Builders. So we have about 30 minutes of deep energy retrofit products. And because we're not really talking about the actual energy performance, the processes and techniques we use apply both to if you designed it to the interfit or if you designed it to the kind of hot 2000 energy model. Thank you all for joining. I guess look forward to you guys actually using these videos to help improve the skill level of builders and designers in cold climates, Alberta.
Nice work. Thanks, Frank.
Thank you all for coming. Next month, the talk will be on another grant that Passive House Alberta received. So we'll be talking about all about electrification without a service upgrade next month.